So let's see, recording. Okay. I want to make sure I'm actually, okay. Yes, it is recording. Okay. I was supposed to record our last study session, and I guess I forgot to click the record button. But anyway, so this is, I think we have a total of 8 questions here that we can do. I don't know if we're going to be able to go through all of them, but one that I do definitely want to go through is question 7. Just because I feel like it encapsulates, honestly, a lot of what we might want to know. Oh, there's Eric. Um, Welcome to the call, Eric. Question 7, I feel like really encapsulates just about everything that we need to
I'm
know
in.
to
Hey,
understand. Hey, you made it. Um, we're just
fuck.
talking about what the study plan is, I guess.
Yeah, I guess I'm gonna do this for my test because I choked on the quiz, my Thevenin quiz.
You're not the first person that has told me that. I'll tell you that.
Like if I probably like if I had, honestly if I had more time, I would have like had more time to start over and actually get it right. But like it is what it is.
you're you're not the first person to tell me that. I heard today that it was I don't even know. I heard
Look
that
on eyes
you
short,
needed more
bro.
time.
I kept trying to beat Thevenin. Look, I was getting something close, but not quite. But like, bro,
Yeah, no, I totally get that. Okay, so let me get my notebook out because I do have some pretty good notes what's happening.
so it's
So,
like
um, let's see. So if we here we go, Thevenin. Um, we could okay. So when finding the Thevenin uh, equivalent circuit, or in this case, seeing the Thevenin from the perspective of a load resistor, there's a few things you're going to have to find. You're going to want to find the Thevenin voltage, Thevenin resistance, and then with that, I think you can also just kind of muscle out short circuit uh, current. So there's a few ways that you can find something like Thevenin resistance. Well, let's just go through the process, right? Okay, so first process that we're going to have is that we're when we draw out the circuit, we are going to want to kind of see what the perspective of where our Thevenin circuit would kind of be built off of. So let's see. Here's that. It's not the most straight thing. It's a little slanted, but it's a little. There we go. B. So when it says to find the Thevenin equivalent from, for example, a load resistor, what you'll do is you'll just take that load resistor out, and you'll make that an open circuit voltage. So we'll just label this as VOC, and just keep in mind that open circuit voltage is going to be equivalent to your Thevenin voltage. There's a few things you want to note here. This is going to be voltage Vx. This is going to be 0.5 IY. And then we are also going to have 16 milliamps. And then we have 5 kilo ohms, 20 kilo ohms. And then we have our current here, IY. That's an I. Wow. IY. There we go. Okay. And this is 0.2 Vx. So to find the Thevenin voltage, one of the best ways to start on something like this would be just your method of analysis. So with this, I could say, I have B down here, B, and then this is A, C. There we go. So keep in mind that when we are dealing with uh, kind of a well, I don't even know if you'd want to do like mesh current or anything super specific here. Oh wait, no, hold on. A, B, C, and this is D right here. So with node voltage, you're gonna need like n number of nodes minus one equations, because this is gonna be your ground node. And then with mesh current, it's just gonna be the number of loops that you have. So it looks like this is gonna be about the same, I think. Wait, one, two, three. Yeah, three or let's do node. Let's do node on this one. Node looks like our best shot. So with node, they always say do the easy shit first. I feel like, um, just so we could find our basic node voltage here. So let's see what we got. So we got the 16 milliamps going into node C. So it's just KCL. Yeah, let's do KCL. So B is going to be our ground node here.
Damn, y'all are really gonna do
KCL.
nodal?
Huh?
Damn, y'all are really gonna do nodal? How would this work? Holy shit.
With this one? I mean, you're going to have a
Well,
bunch of
actually, I could kind of
equations.
see it.
Unless, I
It's not
mean,
that much. All right.
what are they?
That shit is it checks out. It checks out.
Hmm. Yeah.
I hope.
Hmm. Okay, wait.
You would
I
also use source transformation for the
I was
16
just
milliamps.
yeah, I was just gonna say this
Yeah,
right
that's
here.
true.
I feel like that simplifies it low key because like we get
Yeah, I'm gonna just do
that
that.
that plus minus. So it'll be 16 times 5. That's gonna be we're gonna have 80 volts.
Wait, but would the current be? Will we still have that IY current?
Mm,
I don't know if we. I don't think we will have
Yes,
that IY current
I'm
though.
because it's in series. We'd still have IY.
I don't know about that because okay, because I don't know. I think the current might be different.
the way I kind of think of source transformation is that although you're somewhat changing the circuit, as far as what I've been able to tell, it's almost like you can keep the what's the word? You can keep the what's the word? The symbols, the sources, the signals, the signal current or something. At least this one I've been kind of like conditioned with VX.
Oh,
Just because it's like you're not like this is still the same circuit in a sense. You're just changing its setup. You're still getting the same like output. That's how I've always seen it.
hmm.
Let's
I
see.
don't, I don't
Should we just
know.
look at the solution now before we keep working on it?
Yeah.
Okay, let's
It's
do it.
IY. Stays the same.
Yeah, for the load.
Did they
Oh,
do
they
it?
do source transformation. Yeah, and they
Oh,
leave the
shit.
IY
Okay.
there.
Huh.
Boom. Okay, so IY is not a super impact. Oh no, IY. Source transformation is not a super detrimental thing to do on
Might as well
your.
just add those resistors in series. At least that's what I'm gonna do.
Yeah, no, that's valid. All right, let's see. A and we got B plus minus VOC. This is VX right there. Plus minus. So am I wrong in saying that VX is also equal to VOC? Or
No, that's valid. They're in parallel. You could test it by just doing a simple KVL.
true, true. It's a good point. Okay. So whenever I get a circuit that has kind of like these signal, like this signal IY or VX, I always try to find what that actually is. Uh, just because, I guess. But thankfully, it looks like in this case, let's just KVL this left side. So let's keep in mind, this is almost like having two different circuits because nothing can flow through the single wire. So let's KVL the left-hand side here. So we're going to KVL just the stuff. I don't have a label or anything, but I'm going to say an 80 volt rise minus, and I'm just going to say 25 kilo ohms times IY minus 2VX is equal to 0 is what I'm getting. And then, so IY VX with this right hand side, we could KVL like Eric was saying, like just this right here, but that's not really going to give us any more information. Like it's not going to give us anything new. but we would probably be able to find what like if we I just want to like I want to include this current source here. So I'm gonna say KCL
2V. Hey, ain't that 0.2
A.
VX?
Yeah, sorry, that point doesn't look there you go. So KCL, so that's gonna be 0.5 IY. And then I'm gonna say plus 50 wait, how would this go? Would it be if you have V equals IR, you have I is equal to V over R. So you would have VX over 50 kilo ohms. And then I don't think you would have, there's obviously no current coming in from the open circuit voltage. So we set that equal to 0. So then I'm thinking, put this in terms of IY, plug it in there, solve for VX, and then you're golden. That's what I'm seeing. We got 0.5 IY equals negative VX over 50 kilo ohms. Boom. And then we're going to have IY. This is basically like multiplying both sides by 2. So it's going to be minus VX over 25 kilo ohms is IY. Then I'm going to plug that in over there. So I'm going to move the 80 over also to the right-hand side. So I'm going to get negative 25 kilo ohms times negative VX over 25 kilo ohms. Oh, look at that. Minus 2 VX is equal to negative 80. Sorry that my handwriting is very messy also. So I'm seeing this cancel, the negatives cancel. So then this VX plus the negative 2, that's going to be negative VX is equal to negative 80. And then VX is equal to 80.
Why are you canceling the 0.2 VX?
I didn't really cancel it. I just combined it with VX here. So this 25K canceled
Well, it's
with
0.2.
Oh, do it
Not
be 0.2.
2.
Oh, you're right. 0.2. Okay. Right. Okay, that changes things. We end up with 0.8 VX is equal to negative 80. Yeah. And so then this is going to be VX. Would it be 80 divided by 0.8?
Mhm.
I get negative 100 volts.
Yep.
Nice. So it looks like our signs here, if you flip these signs for the open circuit voltage, that would give you the positive 100. Okay. So, we know Vx is equal to VOC. So then we can just say, hey, V Thevenin is equal to, this will be negative 100 volts here. Let's double check our work. So we have KVL, KCL, 0.5, negative Vx over 50. So the IY becomes negative Vx over 25. And they got, yeah, negative 100 volts. Look at that. Boom. Okay. We're on the right track. Now we need to find the equivalent resistance. That one's not too bad. We can leave this as it is. Possibly.
Hey, okay, wait. Okay, you have IY equals negative VX over 25 kilo ohms. What's going on with that?
Say again?
What's going
This
on
right
with
here?
the IY equals negative VX over 25 kilo ohms?
You just got rid of the 0.5 on the left-hand side.
Yep.
So you just
What happened?
multiply by 2 on each side.
This
What?
is the KCL on node A over here.
Yeah.
So this is 0.5 coming out. And then I have 50 kilo ohms coming out here. This Vx over 50, this is the equation for current through the resistor because it's Ohm's law. And that's equal to 0. And then I just put it in terms of IY.
Yeah, okay.
Yeah. Because then because then I substitute IY into the KVL equation. With that, we get negative 100 for the Thevenin voltage. So then let's see what else we got. So we want to find our R Thevenin. So if I'm right with R Thevenin, there's two different ways you can do it. The first one is that you leave it as an open circuit. And when you leave it as an open circuit, what you do is you remove all of the independent sources. Or there's the other way, which is to create a short circuit. And by creating the short circuit, you still leave everything in it, but then you just kind of change the equation, and then you solve it from there, and then you solve for the short circuit current, which I think that then having the voltage and then the current, you can use that to calculate the resistance, as the resistance would be R is equal to V over I. So let's look at this circuit here again. I'm just gonna keep the source transformed equation that we or circuit that we did. So I'm gonna say plus minus, and then here we're gonna have first resistor, second resistor, and then we're gonna have this, and then we're gonna have that. And then we have node A and node B, 50 kilo ohms. We have plus minus Vx, 0.5 IY. And then we have IY there. And then we have 80 volts right there. And then 5K, 20K, 50K. Okay. So the best way to do this is you just add a short circuit to it. And then we'll just say that our current is flowing downwards. So ISC. Keep in mind, ISC is equal to your Thevenin current there to an extent. Yeah. Or like a test type voltage. Let's just say high Thevenin there. So by having this, we're going to short out this resistor here. So by shorting this out, the voltage across it does become 0. And so this 0.2 Vx, this voltage becomes 0, meaning the voltage across this is 0, meaning this gets replaced with a short as well. And then what we essentially are left with is plus minus. I'm just going to write this as one resistor, and then we're going to have this. And then we're going to have basically this. And then we have like a ghost resistor there. And we have 0.5 IY. And then we have 25. And then this has the current IY flowing through it. And then we have 80 volts. So I could be wrong. But here's what I'm thinking, right? Like, let's just label all these nodes, right? This ghost resistor does not matter whatsoever. This is one big circuit. So I'm seeing this as so if this current is flowing down this way, let's just imagine like this current flowing around like this, right? So I see this as I short circuit is equal to negative 0.5 IX. You probably get the same answer if you like here. Let's actually do it like an actual formulaic way. I'm going to KCL node A. And so I'm going to get 0.5 IX is the way I do KCL, the way we've kind of seen it is that from our node, we assume that all the currents are flowing outwards and then we add them together. So +5 and then plus ISC. And since we have nothing else, we just say equals to 0. So yeah, there's my proof there. Negative 0.5 IX.
Sorry, quick rewind. For just we're dropping all dependent voltage sources.
No. What we're doing. So there's two ways you can find Thevenin resistance. The first way is to leave this side over here, like this right here, as an open circuit. Oop. And then what you do is when you leave it as an open circuit, you remove all of the independent sources from the circuit. And then you kind of calculate from there. But because this equation has two dependent sources, and I'd only really be getting rid of this independent voltage source, it doesn't change too much. So instead, there's another method where you connect the A and B terminals, and then you do a short circuit current across it. You leave the circuit as it is, and you solve for our Thevenin.
Okay.
So
why do we drop the dependent source then of 0.2 VX?
We dropped the 0.2 VX because by having this short circuit wire here on the side, let me see. I wish I had like a.
I don't know. I can't think of any cases. I can't think of any case that you ever drop a dependent source.
Well, it's not so much that I dropped it, but let me explain my reasoning here. Look at this. So we have the short circuit here that's flowing here from A to B. That means that this resistor kind of gets shorted out. It doesn't matter.
Yeah, because in parallel, I get why.
Yeah.
But at the same time, it's like, I don't know.
So what's the voltage across something that has no current flowing through it? It has nothing. Like there's no, like it's bypassed. It's a bypassed resistor, right? So the VX would be 0. Right?
Oh,
the current, think of it. There's
Never
like,
mind.
even if we did this with an equation, right? Let's say V equals IR, your current is 0. So there's 0 current flowing through this resistor, meaning that the voltage is going to be 0, right?
Yeah, I got you now. I understand why you didn't drop it. It's just that it comes out to 0. So
yeah, exactly. Yeah, because it's still here. Yeah, exactly. It's still here, but the thing is,
it just makes it cleaner when you're looking at it.
Exactly. It's 0 volts. And what has 0 volts across it? A wire, right? So, yeah, actually, I think I might just leave that reasoning there just so we can have it for later. So that's why I ended up just kind of not writing it this time around. But then again, I probably wouldn't be as bold on the quiz. Like I would probably still have it as a placeholder for my equations, and I know that I'd just be putting in 0, but we can be a little bold here.
Hey, why is the 25 kilo ohm? Why'd you make it parallel to the voltage source?
It's not. It's in series. Oh, I just moved it to the side.
Oh, because we moved it to the side. It made it think like it was. I'm like, huh? When did we?
Oh no, it's all good.
Like I'm not in series.
Oh, you're good. Okay, so let's see. So what is?
You can find IY like right now, actually.
We could. So IY is equal to the 80 volts divided by the 25K. And okay, hold on.
Negative 80 over 25K.
Wait, negative? Whoa.
Oh wait.
So down there.
I don't think that would be the case.
I think it would just be positive 80 on that one.
Yeah.
You're good.
You're talking about it. All right, sure. Yeah, that'll be some negative thing.
No, you're good.
Okay.
So
I mean, peeking ahead, but the solution does say negative 80.
I don't know about this now because like we can't.
The solution says negative 80.
Yeah, that's what I was looking at.
Why is it negative? Yeah, because
why is it negative?
I mean, I get why, because I'm like, wait, we have a negative I current. Resistance can't be negative.
Resist.
Oh, you're right.
So that's why I'm like, wait a second.
Wait. Say that again with the resistance.
Resistance can't be negative.
Last time we already calculated
Wait, their V
IY in
Thevenin's
the last
negative
equation.
100?
Oh,
Oh, never mind.
wait.
We calculated IY in the last equation, which is VX over 25 kilo ohms.
Okay, we calculated
But-
similar there. We had the same.
But wait, that's different.
That was
Whatever.
for our old equation.
Yeah.
This is different now here.
Why is it negative then?
But yeah, I don't get why it's negative.
Oh yeah, I see why it's negative. Never mind. I forgot to put the minus sign. Shit. Never. Okay, we're on the right track.
What minus sign?
Why is it negative then?
Because our voltage, our Thevenin voltage is gonna be negative. Well, it was
Yeah,
negative.
but we're not using that in this one though. We're still using
No, but
the
like
80.
when we to get the resistance, we gotta divide them. Resistance gotta be positive. So both of our Thevenin shit gotta be negative. So when we divide them, we get a positive resistance.
Oh. Okay.
Remember we got the negative 100.
Yeah.
My
I
only
don't think
beef
that
is
would
the
have
value
anything
for
to do
the
with
value they
finding the
got for
current of
short
IY, though.
circuits different.
There has to be a more not consistent, but a
Or
more
is it?
reasonable explanation for it,
No,
other
no.
than
What
just
is-
like we want it to be positive. Like I don't.
Actually,
80, 25.
wait, never mind. We're on the right track. Yeah, we're good. We're solid. We're
I
solid.
is
We're
equal to
solid.
voltage over resistance. So it's 80 volts divided by
Because of passive
25.
sign convention. It's
Is
going
that-
back to the negative.
Is that why? I always forget about passive.
Oh, I guess, yeah, you could say plus minus. So instead of negative IY, we move it over to the side.
No,
Yeah.
it's going through the it's going through the negative of the voltage source. So it's technically negative
Yeah.
80 over 25.
That's stupid,
Negative
but
80.
yeah,
No,
I see it.
I was second guessing myself on passive sign convention. I was like, I don't know if that's right or not, but
like
we've had a lot of friction with people using electron flow and conventional flow, and
What the hell is the difference?
it's not getting any better. Okay.
Anyway, yeah, we're good. Was it asking for any maximum power or something?
Yes,
That's
it is
case,
asking for
our
maximum
load
power.
should be the same as the okay.
Calculate maximum power. Okay, so if IY is this,
At short circuit, it's negative 0.0016 amps.
80 over 25K. So would that be 80 divided by 25,000 times 0.5 at 1.6 milliamps? Did you guys get 1.6 milliamps for the short circuit current?
Oh, I haven't calculated. Yeah, I'm still thinking about why it's negative.
Yeah.
Is it? I don't know. If the current's just going in a loop, I guess it doesn't agree with passive sign convention, but
it's negative because the 80 is the one that's negative. So it's taking that negative sign and putting it in front. Because the 25 is positive. We know that resistance can't be negative. So it's basically negative 80 parentheses and then divided by 25K. So it's like that's basically why it's negative. You know what I mean?
You're talking. Are you in Fahim's class? You're in Fahim's class with us.
Yes.
Because here's the thing, right? Okay, hold on. This is gonna be really extra. I'm gonna KVL this shit. If I KVL this, we have 80 volt rise minus 25K IY equals 0. Yeah. Negative. Wait. 25K IY equals negative 80. IY is equal to 80 over 25K.
Minus 80 over 25K. Or minus 80. No, you're right.
Right? This is like, man. But then I also understand, I don't know who it was. I think Eric said you can't have a negative resistance, which is true.
Well, yeah, we're on the right
because-
track. We're solid. That I short's gonna be a negative though.
Yeah.
So that's
gonna
negative
be-
1.6 milliamps.
So okay, we do know that she makes mistakes all the time.
Yo,
That's
that
true.
80 over 25K ain't supposed to be negative.
I really don't think it's supposed to be negative
It's not. So
because
she's
you just
tripping.
proved it with KVL, right?
Yeah, she's tripping, bugging, and wilding right now.
Yeah, it has to be a typo because for I short, it's
The I short's gonna be negative.
yeah, it's negative 0.5 IY, and then inserting IY, it's still negative. So it has to be a typo.
Yeah, and that's fine. That because hold on, because look at this then, right? Like let's say we calculated our max power. So this is gonna end up being if I plug so I got this would be negative 1.6 milliamps right there. So I'd be negative 1.6. Technically, if I were to calculate the power, keep in mind power is the voltage times the current.
Squared over.
But yeah, then they say power max. The power max formula is what the hell is the power max formula?
It's V Thevenin squared over 4 times RTH.
V Thevenin squared over 4 RTH.
Yeah, can someone check that for me though?
Wait, oh well, we still need to calculate resistance then. So resistance.
2.5 kilo ohms.
It would be
Like yeah, that's what I got.
R is equal to V over I. So it's going to be negative 100 divided by negative 1.6.
16.
So that's going to be
0016.
Yeah.
We all got it in millions, whatever.
Divided by negative 1.6 milliamps. And that's going to give me 62.5 kilo ohms.
Yeah.
There you go. And so then this is obviously going to be 100 squared. So this will be 10 to 3 over 4 times 62.5 kilo ohms right there. So, and that's going to be that divided by 4, 62,500. Oh, fuck. That's a big number. How is this?
But yeah, Angelica is not going tomorrow because of the end, and it's not going Saturday because it's the end. And then it's not going Monday and Tuesday because I can't.
Our Thevenin, should I just do like? No, that's not a happy number. How the fuck am I getting? Like, I'm getting numbers in the millions here. That's not 10,000. Then we're gonna do.
Bro, I got 40 watts. I got.
Yeah, what? Now I got 1 over 25. What?
They're bugging. She's bugging. I got 40 milliwatts. She's bugging. I got 40 watts. Wait, okay, wait, what the hell is her P-max formula?
That is negative 10, negative 100 over.
Oh wait, do they want the power of what do they want the power of a specific resistor?
Mm,
of
yeah,
the
maximum
load.
power to the selected load. Okay, so that would
Okay,
be.
I got
Oh, that you have to.
watts.
I think I know what it is. So if we have, okay, look, this is going to be positive, negative like this. If we want to keep it as 100 volts positive, then
Mhm.
this is going to have 62. Fucking what is it again?
Yeah, 0.5
60.5 kilo ohms. And so the maximum power load, I see it's a trend that if it asks for the maximum power load, because we don't know what RL is, like this is just like, oh, load resistor. I've always seen you just kind of double it in a way,
Yeah.
which makes sense. Uh, so
Her form was looking crazy. Like what?
yeah, okay. I'm just gonna switch the signs here. That way we get the negative 100. Okay, we're gonna look at her. Hold on, let's look at the notes.
Sweet Thevenin, she messed up somewhere because that.
Where does the 125,000 come from? That's what I'm stuck
That's
on.
a good question. I don't know.
Adding both.
The
resist-
125K squared.
But
If you
that
square
doesn't
both.
make that doesn't make sense.
I know, but that's the only way I can think of where she got the 125K.
That's wrong.
Where do you say she got that from?
She
By
probably
adding both resistors.
Yeah, but you don't do that for the formula.
Well,
She's so this
V
is
over R.
no, this
That
ain't
makes
it.
sense. That makes
No,
sense.
it doesn't.
Oh,
No, because you're finding the current, the current, the yeah, that's the current.
that so power max is basically just doing current times resistance, which is why it's I squared times R.
P max
Max
is
what?
the
Hold on,
current
this is-
squared times resistance, or I think there was another way of doing it. I can't remember though. Oh, wait, max power. Here it is.
Okay, hold on. There's another formula. You got me pressed now. Hold on. Let me Google this formula real quick. Got me pressed.
There it is. Yeah, I squared RL. Oh yeah, look at this. This right here. Power to the load is equal to the V Thevenin over the R Thevenin plus R load resistor. All of that squared times the RL.
Yeah,
So
but
this is
okay. Yeah, that's the
RL.
other version of it. But then her denominator's got to be that one. What you call it? That 125 too. If she's gonna do that one.
Yeah. So this becomes PL. So keep in mind, this is our V Thevenin, so negative 100 divided by, and this is gonna be 62.5 plus 62.5, and this is all obviously K, right?
Well, I got the same answer.
Squared times the resistor that we're looking for. So it would be 62.5 K here.
Well, I got the 0.4, what you call it, the milliwatts or whatever.
Right. So this would be something that's good to have on the cheat sheet for sure. Which we should probably make one actually, now that I think about it.
Yeah. Well, like I got 0.04 watts, so that looks. Or you could, or the other way, the other formula for it, it's just VTH squared up top. Then on the bottom, it's 4 times R Thevenin.
4 times, wait, hold on, 62,500.
You'll get the same answer. It's easy to remember, though. I'm still going to put in my formula sheet.
Oh, yeah, I'm getting 40 milliwatts. Yeah, I'm getting that.
with the equation we just got.
Yeah. I got 0.04 watts, which is, that's 40 milliwatts.
Yeah, same.
So power max is the same as power load? Like that's
Yeah, these are like the same equations. I think this one
just in
down here
different
is
formats.
just this one down here is just assuming that we don't know what the current is, I guess.
Gotcha.
Now hold on. Now let me do one more thing. Let me just 10,000 divided by 462,500. This equation also works. This equation also gives 40 milliwatts. Oh, wait, this isn't. Where's the notes? So if we want to find the value, so I don't think we're going to have to do this ever. Finding the value of RL such that PL is the maximum. Oh yeah, because look at this, because it's the same. Duh. RL is equal to R Thevenin. That's what we would need. Oh shit. I just turned my laptop off. Fuck. Hold on. Turn back on.
Uh-oh.
All right, let me turn it back on. That's my bad.
You're good.
There we go. Let's get back in this call here. Damn, it always insists on turning on my webcam. All right.
Oh shit!
Are we,
What?
are we still recording? I just want to make sure. I just have that now.
I have no idea.
Back of my mind. We are still recording. Okay, that's good.
Yeah, but I got 40 milliwatts. I know you're already way past that, but I also got that.
No, that's good. That means you're doing the process right. That's
Yeah.
good. So yes, this is another form of doing the equation. So I'm just going to get my little green pen here. This is valid, as is PL is equal to, this is V Thevenin over R Thevenin plus RL squared times R Thevenin. Okay. Okay. And then we also have this equation is valid. So we have these three equations that can help us calculate the maximum power. Perfect. Okay. So let's do
V Thevenin squared over 4V R Thevenin is also valid?
Yes. Yep.
Okay.
Which kind of makes sense because like if you have like R Thevenin and RL are the same. So think of it like that, think of it like R squared, and then if you square that, you multiply the exponents together or whatever, that becomes
Yeah.
Wait, no, shit, that's the wrong way to figure it. 2, that becomes 2R for, you know what? Just write down both of the equations. I'm not even gonna like try to like fuck myself over trying to remember like the like exponential
Nah,
rules
I'll
here.
just memorize it.
Oh man. All right, let's see. Question number 2. I think this is gonna be a pretty solid one. Sometimes OneNote likes to freeze on me. There we go. Oh geez. This is not it. Okay. This is problem 2. I'm gonna zoom in a little bit. I feel like my handwriting is at least marginally better when I'm zoomed in. So let's see. Plus minus. There's that. Minus plus. A, B, 12 volts. X, 4 kilo ohms. 4 kilo ohms. So we're going to find the Thevenin circuit. So this is open circuit, V Thevenin. So I'm going to tell you right now, this not looking too bad. Not looking too bad. And here's kind of why. Well, this little sign, the signage on that dependent source kind of trips me up a little bit. But here's what I'm thinking. There's two ways to do this. Node voltage, mesh current. To find, so first step, find V Thevenin. So with this, I can tell you that we're going to need like, okay, so if we did with node analysis, this is going to be, this will be like C. This will be B. We'll probably have like two equations and we're knocking it out. Now, the one thing that bothers me is this well, we technically have a node here, which would be D. So let's do both ways. Let's do node voltage method first. Just because I could use some practice in that. First rule of node voltage is to do the easy shit first. So VC is equal to 12 volts. B is going to be our ground node. Now my second equation is going to be KCL node A. So the value at node A is actually our V Thevenin. So I'm going to say, like Ms. Fahim does, she assumes all the currents are flowing out of node A, and we're going to add them all together. So I'm going to see, I see V Thevenin minus VB over 6 kilo ohms. That's a 6. Plus V Thevenin minus VD over would I say negative Vx over 2 since it's the negative side of that equation? That's the one I'm kind of stuck on. Okay, let's see. How did she do it? KCL node A, VA, VC. Oh, no. Never mind. She just says VA minus VC. Okay, never mind. I was overthinking it. I don't even know why I was. Yeah, I don't even know what the hell I was thinking there. Okay, anyway, yeah. 4 kilo
Okay,
ohm.
do we real quick want to switch the nodes so there isn't confusion later on? She has D as C and C as
yeah,
D.
let's do that. D. So we'll do this C, V Thevenin, VB. So this will be VC. And this is VD. Perfect. Okay. One other easy thing I kind of overlooked. Another easy thing we want to keep in mind. This isn't an equation per se, but Vx is equal to IR. So that would be, if I remember correctly, we can set this up as 4 kilo ohms times VA minus VD. Or I'm sorry, no. Flip those. Look at the signs on it. It would be VD minus VA. I'm pretty sure that's allowed. I remember doing something like this in class for voltage. Well, I guess we'll see if that works out. Okay, anyway. Does it work out? Yo, BC. Oh, it was. Okay. I gotta stop looking at that. I gotta do it the right way. I gotta stop depending on it, you know? Okay, so we got that. And then I guess I can say plus, and then although I could say plus, wait a minute. I know what was confusing me. This goes V equals IR, meaning I is equal to V over R, meaning the current there is I could say that's why. Okay, so no, wait a minute. I'm just overcomplicating it again, honestly, because Vx is the same as VA minus VD, you know? So if I'm really going to do VA minus VD over 4 kilo ohms, or well, this would be VA would be V Thevenin. There's no issue with that. I don't know why I had to complicate it too much. So there's a few things we can do in here to kind of make our lives a little bit easier. For example, we know that node D is 12. And as our kind of sneak peek happened, we don't know what our voltage at C is yet. But because we have this dependent source there, we can easily say that voltage at C is equal to, it's going to be, yeah, because it's the negative side, negative Vx over 2, which would be VA minus VD over 2 there. And let's just confirm VA minus VD minus VA. Oh my gosh, yeah. I even called that out when I was writing the equation earlier. VD minus VA there. Okay. That was a lot. Are we all feeling good though? You all see what we're doing there? Okay. I don't hear any.
Go over your KCL node A real quick.
Yeah. So
Just
my KCL,
quick, like,
yeah. So VA is, I just see it as my Thevenin voltage because it's attached to the Thevenin. So I go VA minus VB over the 6 kilo ohm is my first one. VA minus VC over 4 kilo ohms. And
okay, so you just labeled your V Thevenin as VA.
Yeah, yeah. And then I did V Thevenin minus VD over 4 kilo ohms. Now, what I was gonna do earlier, actually, I'm somewhat vindicated on that because VC, this equation, I was worried about what the voltage at C was, and we're gonna substitute it in now. So we have V Thevenin minus, we know VB is 0, 6 kilo ohms plus V Thevenin minus, and then this is going to be VD minus VA over 2 all over 4 kilo ohms. That's a lot. Holy shit. Okay. Got that. And then we do plus V Thevenin minus VD, which is 12 over 4 kilo ohms. Perfect.
So for
this should be
VA minus VD or
VD
Thevenin minus VD,
and this will be 12.
Are we just flipping that so that we all get positives?
So that we all get,
isn't that going out of node A?
Yes. Yes.
So we're just flipping it.
Yeah, the way Miss Fahim kind of does KCL is she'll have a node, for example, and let's say this will be node E, and this will be connected to like a bunch of other shit like this, you know, and this is like a thing or whatever, and it's pointing out another resistor. She'll assume that all currents are flowing out of that node. And what's nice about that is it's a little consistent because let's say that's E. Now let's say that, oh, come on. Okay. You have node A over here, B and C. Your entire formula is going to be like, for example, VE minus VB over whatever that resistor is, plus VE minus VC, whatever. Well, this should be a resistor, a resistor. To, and then you have plus VE minus VA, which is over here, over R3. So that's the convenient part. Because if you were to like give a polarity to everything like positive, negative, then you're kind of confusing it, because then you could say like, okay, this is leaving here and then this is coming in. And so then you'd have like, it's best to keep it simple,
Yeah. Okay.
Yeah. That's how she does it.
Her do it that way before.
I remember she introduced it like that when we first started node voltage. But it's just been all over recently. Because sometimes her slides do change, like that just changes it up,
Fortunately.
Yeah. Okay. I'm not a fan of this right here. All these fractions together.
Yeah, me neither.
So I'm gonna let's see. I'm gonna rewrite this a little bit, maybe in a little bit of a simpler form. 6 kilo ohm. I'm gonna move this over to the left hand side here. So I'm gonna say Thevenin minus 12 over 4. I say plus, and I think I'm gonna split this up actually. I'm gonna say plus Thevenin over 4 kilo ohm. I'm gonna say minus, and I'm gonna make this. If I'm right, you kind of crunch these two fractions together here. So this will be 12 minus Thevenin over 8 kilo ohm.
Our first step should just be getting rid of the fraction. So multiply the whole equation by 12, for example, to cancel out all the fractions.
That's true. That's yeah. So
that's how I do node and mesh.
No, that's absolutely right. You can do that. You can multiply it by 12. That is a common denominator of all of them. Personally, what I do is I maybe my version is a little involved. Let's see, 8, 24. So for me, I see that 24 is kind of the common denominator for all of these. So I'll multiply this by 4. So this will be 4 Thevenin plus 6 Thevenin minus fucking what's 12 times 6? God damn, 72. Long day. 72 plus 4 Thevenin minus 36 minus 3 Thevenin equals 0. God damn, I hope we got this right, boys. All right, let's see. 4, 8 minus 3, 5 plus 6, 11 Thevenin. And then I'm just going to move these two over to the right-hand side together. So let's see. We got 108. Thevenin is equal to 108 divided by 11. 9.8. Wow, I don't like that number. Damn, that is not the right number. Okay, what did she do?
I'm still in the midst of working on mine.
I hate how like she'll say VD is 12, VC is that, node A is this, and you get this. What? Where's the math? This doesn't help me. Okay. Thevenin. So we know VD is 0. Or wait. Wait, Thevenin minus 0 is 6 kilo ohms. VA minus VA minus VC. I went wrong somewhere in my math here. I think I see where I went wrong on this. So this became 4. That became 6. This should have also become 6 right here. So it would have been 6, 12, 16, 13. 108 divided by, is that going to change much? No, but we're getting a smaller number. Okay. Obviously, my algebra was wrong here. So let's just nuke it and we'll just do it again. Okay. V Thevenin over 6 kilo ohms plus V Thevenin over 4 kilo ohms minus, oh, that could have been where I went wrong. Maybe. Minus 12 minus V Thevenin over 8 kilo ohms. If there's one thing I know I'm bad at, it's distributing negatives to the numerators on fractions. So this is going to be 3 V Thevenin, 6 V Thevenin, minus 36 plus 3 V Thevenin. I think that's right. Let's see. Come on. Plus 6 V Thevenin minus, it was 72, right? Yeah, 72.
I'll be honest. I just typed the equation into Symbolab, and it gave 5.6.
Oh, geez.
So I did V over 6. I just typed in V for the variable. V over 6 plus V minus 12 minus V over 2 over 4. Yeah, I did that exact equation and I got 5.6 for V.
Yeah, 108 divided by 18 is going to be roughly,
I got
Well-
2.77 volts. What's the answer?
yeah, it's 2.76. Where
Oh shit.
How did you do that?
something's up with my algebra here. It's got to be with me splitting it here.
That's
That's
a pain
probably
ass, dude.
why.
I got stuck to the end because I was doing all these fractions. I was going crazy on my calculator trying to convert it into like a fraction. And the thing is, only does
Yeah.
it to a certain moment where if it's too small, it's like, yeah, you're not getting a fraction. So I had to wing it and do smaller
Yeah.
numbers. So I could predict
you
like,
know
okay,
what?
it's gonna be something like this. But yeah, that's what I got.
VC is negative. That's why we're getting it wrong.
What the what'd y'all
We're
do?
just subtracting 12 minus V over 2.
Oh.
We're not, so it would be plus.
So this would be plus here.
Yeah,
which makes
now that I do that,
plus
That's a good.
it immediately
minus
changes it to the And I
That
immediately get the right
AC.
answer.
VX. VD. Why is it negative?
Because from our
Oh, because of the
yeah,
wait.
the negative VX over 2.
Oh my gosh. Yeah, I even said that earlier. Yeah, I
yeah,
remember
and
saying
we
that.
forgot.
I can't believe it. Yeah, even look at that. Look at it. There you go.
Yep,
Oh my gosh.
it happens.
Dude, that's linear circuits for you, bro. God dang. All right, let's see. So 36 minus 72. So that makes this side 36 here. 3, 9, 6, 12. What?
Wait, well, hold on. Oh yeah, I got it.
12 beat Thevenin. That's
It's
a little too round.
No, it's 13.
3, 9, 6.
It should be 4 for the first one. 4 VA.
You're right. It should be 4. My multiplication is now compromised. 13.
Yeah, dude,
Bro.
it's the little things, man. Freaking
It be, so this will be 13. 36 divided by 13. And we get a beautiful 2.76. Wow.
it should be 2.77, but whatever.
Well, if you round it to 2 decimals, yes, that is true. Oh yeah, which she did. Duh. Yeah. Okay.
Yeah.
And now we could easily do our Thevenin.
Yeah.
Mm,
Yeah, it's
do
not too
that.
bad.
What a nightmare, dude. Like,
Oh. Bro, come on. Okay. Whew. Thought my OneNote was crashing. Alrighty, let's see what we got. A, B. We got 4 kilo ohm. 4. Uh-oh, my laptop is not having a good time. Okay, 12. Short circuit. That's gonna knock out our 6 kilo ohm resistor. After that, we're gonna have our I short circuit there. Or no. Let's actually have that flowing downwards. Come on. There we go. Dude, I literally feel like Miss Fahim when I'm like doing this thing. I'm like, oh, hello. Like, god damn. It's like ISC. Oh, you're getting a message. Okay. Plus minus Vx. So for this one, this all becomes a. My OneNote is starting to. Okay. God damn. Okay, so this all becomes A. Oh my god. Okay. This becomes. We'll make this B. We'll make that C. So I could let's fucking node voltage, I guess. Or something. Okay.
It's so good.
So we got VC is going to equal 12 volts. VX is going to equal VC minus VA. Are we doing like a node voltage on this? I'm inclined to say that we are.
We can do KVL around the whole loop, like the big loop,
True.
and just do 12 minus VX.
Wouldn't? Yeah, you're right. You're right.
Because we're just going along the short circuit.
Uh-oh. Yeah. Uh-oh, we're running out of room. Okay. Why is it doing that? What is going on with? Okay. I didn't do any of that. My laptop's just turned. Okay. KVL. CAC. So we got 12 volt rise minus VX equals 0. So
So we just have VX equals 12.
could I say 12 minus VC minus VA is equal to 0? I mean 12 minus 12 plus VA is equal. VA is guaranteed ground node. There we go. Okay. That's lovely. I think we need to no, we need a different approach on this.
Let's just VX equals 0, VX equals 12. And then we can plug that into the dependent voltage source.
VX is 12.
Because we're just doing
Yeah.
KVL around the whole thing.
Yeah, you're right. You're right. So VX is just equal to 12. So that makes this 6. Oh,
Mhm.
shit. 6. So
So we
let's
can do
just
another KVL.
yeah, I'm thinking KVL like this, maybe. See it, yeah, I mean it's the same. Okay, so we got 12 minus this, that's my sign notation. Minus 12, okay, plus 4.
Wait, what are you doing?
No, wait, what am I think I should I'm actually getting stuck on this. Hold on. Finding our Thevenin. Find our Thevenin by finding our short circuit current. Short circuit current is flowing. So if it's flowing this way, I'm going to assume it'll flow this way, I guess. So we're going to KCL. Okay, so I think we should KCL node A. Because then we'll get VC minus VA over. Oh, no. You can't KCL your ground node. You can't KCL your ground node. Wow, am I really like, I'm really tripping up on this one. Short circuit, KVL. 12 minus VX. Okay, VX is 12. Okay, we got that. 4K. Oh, so we just assumed our currents here. So we would KVL 4K I4 V2. Oh, so we KVL this here. And then we KCL I don't know if you can really KCL node A here. Isn't that what they did?
A KCL
Or did they do
IX going? Yeah,
yeah,
they
they
did.
KVL'd IA.
Well, to be, they're having different like. I don't know.
Okay. God damn. Okay. So they say VOC 2.76, I short circuit is equal to. Why is it 1.5?
Let's see. Still working on it.
Where do they do KVL?
They did KVL here among this loop here. So they went from here across,
I
short
can't see
circuit.
your mouse if you're.
Oh, you can't see it?
I don't know
The-
why. Yeah, it's bugging out. Okay,
Oh man.
I can see it now.
Okay. They went like this. That's what they did.
Okay, I see it.
Uh,
Oh, I hate that.
okay. So before it gets any later, I wanted to finish on a strong note and a strong one. And that one is the second to last question. Question number 7.
Oh
Now,
my gosh.
we don't quite have to find everything. Although it's always good practice. But we just need to find the Thevenin equivalent and the R Thevenin. That's all. And then we could probably call it a night or something, because I also am trying to get a good night's sleep before the quiz tomorrow. So let's see. But how are we feeling so far on Thevenin? Yay, nay? I'm not a fan, but
I mean, I'm not a fan. We'll see. Did she
Minor.
say anything about dropping quizzes?
The
So
lowest one gets dropped.
are you
Well, I
wait,
don't
Eric,
see
are you in our
anything about
class?
it on syllabus.
No,
Oh,
but
there's nothing about
every
it on the
LC
syllabus?
teaches the same thing.
Yeah, but you don't know with her. One time she promised 3 and then she only dropped 2.
Yeah, that's
She's actually dropped 2.
yeah. That was last
What the
semester.
hell?
Yeah, she promised 3, but then changed her mind.
That makes no sense.
Okay, now you got me looking at the syllabus now. Hold on, fucking goddamn.
Yeah, look at the syllabus.
There's not a mention drop quiz.
There's not a mention of it, but I feel like how can she
I mean,
not?
the standard is the lowest one gets dropped. Normally.
Yeah.
Well, you don't know though. She's whack.
I mean, yeah, but like I said, the standard, they so quick to uphold the little standardized bullshit for LC. This is my second time taking it too,
Last semester, she did drop 2. What scares me is that this time around, she said uh that we have to do good on our quizzes, and she said like because they all count for your final is what
Right.
she said.
That's
And
what
so
I didn't hear exactly what she said because I wasn't really paying attention at that moment. So I was like stressing the entire day today, wondering what she meant by that.
yeah, I that's been on my mind also. I'm like, wait. Does that mean you're not dropping anything? Like
That would
so
be
yeah,
bullshit if she doesn't drop anything.
that's true. Unless I'm thinking like kind of like last semester we were always saying like don't ask about
Curve, yeah.
a curve because then she will either flub the curve or she won't give one. So I think that
Exactly.
she's just saying this. I think she just said it so that way those who haven't taken her, they're like, oh shit, like I gotta do really good on all my quizzes or else I'm gonna, you know. But it's
That's
smart because I don't want to go about this class thinking about a curve already, you know. So yeah. Okay. So let's find our V Thevenin here. Wow. V Thevenin. So okay. Here we go. I'm gonna change this one up a little bit. I'm gonna do mesh current on this one. So just a few things you want to keep in mind when we're doing this. 0.1 Vx is equal to, oh, this is IA, by the way. This is IB. This is IC. Now, IC is an interesting one because IC is going to be 0 in just about every instance. Because think about it. This is an incomplete circuit on this side. And you're going to see it pop up a little bit. Like there, you'll definitely notice it. So check it out. This is going to be IB minus IA. This is acting against that current. And then we can also say IY. So we'll just draw a line. IY is equal to negative IB. Right? So see how it kind of shows itself a little bit because look at this dependent source right here. Right? If we did 3 this would be negative 3 IB or whatever, right? For that current dependent source. This is only depending on what B is. Notice how there's no mention kind of IC because IC is 0. But you have to have it as a placeholder. Okay. So we can say that and then there's one more. Vx is equal to the current IA times the resistance 15. So I'm going to say 15 IA. So I low-key think we can actually kind of get an equation here. Just no, not necessarily, but check it out. We're gonna do. This is gonna be what? If I plug in 0.1 15 IA equals IB minus IA, we get 1.5 IA equals IB minus IA. So when I move everything over, I get 2.5 IA minus IB equals 0. That is an equation that we can use. I guess I'm just gonna label it. I don't know if that's exactly a formula, but shit, you know, it's too good. All right. Second one I'm thinking of a KVL for the next equation. I'm thinking something along the lines of a super mesh. So I'm gonna go something like this. I'm gonna go out here, down, cross, and through there like that. I'm going to go clockwise, so that way I can kind of stay with the flow of the mesh currents. So I'm gonna say KVL, that's gonna be super mesh. This is gonna be plus 110 volts, minus 15 IA, minus 5, and keep in mind this negative IB there, plus 3 IY, minus 8, and this is going to be IB minus IC. But just remember, IC is equal to 0. She does have somewhere in her notes, I think, where it says this. Actually, I think I could pull it up right here. Let's see. Come on. Well, it's probably not exactly what she was getting at, but I think it was pretty darn close. Yeah, like this one, IL is equal to 0. There's not going to be a. It's not the best proof, I guess, but I don't know. Anyway, so this just ends up being 0 there, equal to 0. I believe that's kind of how some of the first KVLs go. That's actually not peak yet. It's not peak. Let's see. Let's do some replacement. So I'm going to move the 110 over. So I'm going to say negative 110, 15 IA, plus 5 IB, plus minus 3 IB, minus 8 IB. So that's going to be negative 15 IA, 5, negative 11, minus, am I right? Yeah, 6 IB. So this is what I'm getting there. Now with this, I'm thinking we could start finding currents. I think.
How does she just solve for IA and IB from that?
How does she just solve for I? Well, you can put this into, well, let's see, how do they, oh, that's right, we need 3 equations, so we have,
Well, that's
oh,
she does it. She does both methods.
aha, okay.
But I
IB
don't
minus
understand how
A.
she just gets to IA equals 2 amps and IB equals 5 amps.
Well, let's see if our equations here are right. So this is going to
Oh,
be,
she
now
probably
this
just puts
is,
it into the freaking thing.
she probably does, but we're going to do it the good old fashioned way with algebraic system of equations. So we got 2.5. Well, no, we're going to have negative 15 IA minus 6 IB equals negative 110. And then this is going to be, what's 2.5 times 6? 2.5 times 6, 15. So it's going to be negative 15 IA plus 6 IB equals 0. Cancel, cancel. Uh-oh. I'm not seeing it work out here. I must have gone wrong somewhere on my math. Hold on, 110 minus 15 minus 5. Oh, that IB is positive. Why is that IB positive? Oh, yeah, I made it. Yeah, that was my bad. That should have been just, yeah, that doesn't hold any bearing yet. Minus 8 IB. Yeah, see, so the IC becomes relevant in this case. So that changes this to being minus 5 IB. So that makes it 8, 11, 16 IB. That's what changes. So that changes our system of equations.
Should we just do like a mini matrix? Oh wait, we can't. No, we can.
You could. It would be a 2x2. Yeah.
I
Times 2.5 times 6
yeah, we
gives
should
me
probably just do a
15.
mini matrix. That would probably be easiest.
Go for it. I'm gonna do it. I'm gonna try and do it by hand.
Okay.
Si le digo aquí el mujer, si Rodrigo me puede recoger.
¿Qué?
Sí, sí.
Oye, ¿tú crees que Rodrigo me puede recoger? Mira, no sé si podía en la esto.
Ahora ya estoy en la última. Ahora ya estoy terminando.
Imagínate que termine.
And then did they get 5 for IB? They did get 5 for IB. Okay. Woo.
Oh, you did it the old-fashioned way.
God damn. 5 A. There you go. And then you just get this. And then you'll just plug it into one of our earlier equations. So let's just plug it into, negative 15 IA. So the reason you want to find these currents, because I'm starting to run out of time here, because I do have an exam I have to submit by midnight.
Jeez.
Damn.
Yeah. Yeah, I have an operating systems exam. Equals negative 110. Negative 16 times 5. Negative 16 times 5. And then you're gonna have negative 110 plus 80. This ends up being negative 80. That's gonna be negative 30. So you have negative 15 IA is equal to negative 30, and you get IA is equal to 2 amps. So what you want to do with that, now that you have these currents, you might say, wait, but that's not the Thevenin voltage. Well, actually, she kind of shows it here. You're going to want to do a KVL around the entire outer part. That way you do have a KVL that includes your Thevenin voltage or your open circuit voltage. It's the same thing. When you do that, you're going to have, like in this case, you have the minus 15 IA, minus 5 IB, minus VOC, and you're going to set that equal to 0. Then you're just going to plug in the values for IA and IB, set the equation in terms of open circuit voltage, and then that will give you your answer. To find our Thevenin, they do a short circuit, and then they keep doing mesh. So to find the short circuit, whoa. PowerPoint's always got away with messing everything up. Okay. So our Thevenin, this is her doing it the mesh way. So the short circuit does change things. So IC does become something that has a current at this point. You can almost say like that. I believe that would actually cancel out this. Let's see. Can you see my little? Oh, you can't see the little nub thing, but the dependent source with the 8 ohm resistor, I feel like that would be canceled out in this case. If you were to do, like here they have a mesh IA and IB. So it looks like what they do is, if I can't even highlight. I can't, wait here. I got it. Take it out of laptop mode. Okay. So what they do, this is the same equation for this dependent source in the middle. They do a KVL here on the outer edge of this equation here is this dependent source in the middle. This KVL for mesh IA and IB comes around this outer edge, comes through the 3 IY and 8 ohm resistor, and then they do one more around the whole outer edge. What they do, they put the VOC and then they put the open circuit current in that one. So so basically you're solving for IC in this case, which would be 13.75. And then with that, that gives you your Thevenin resistance. So for tomorrow, if you guys are going to work on a cheat sheet, I highly recommend that you guys write down the Power Max formulas and practice mesh, practice node. Make sure you practice super meshes. Keep in mind, don't forget that you can't do KVL through a current source. It's never bad to have too many KVLs. Sometimes, it doesn't hurt. Having too few KVLs does hurt. And for tomorrow, I know I'm kind of cutting it a little bit early, but if you guys get the chance, I would probably recommend to practice things that we didn't get to go over. I know that test voltage is something that we haven't covered yet. And honestly, she doesn't have a lot of it in her notes. She really has a tendency to do short circuit current. So yeah. And then yeah, the whole ratio thing, also that one, that sucks, but definitely keep that in mind as well. Practice that. And yeah. Definitely practice the ratio thing. Because I could definitely see that, don't expect them to give it to you easy. They had us do a super note on the last quiz. They're ready to fuck us over on that. So
Yeah.
don't leave any stone unturned. I don't think I have anything else that I could recommend. I think I have, I think that's it, right? Node, mesh, ratios. We don't have any super mesh with this. Practice more load resistors. Practice
Didn't we
practice
use a
power
super
max.
mesh?
Huh?
Didn't we? No, we didn't. No,
We did do a few
did.
super
We
meshes
did.
actually.
Yeah, we did.
Yeah.
In problem
Um,
7 with the
Yeah.
AE.
Um.
Mine need to do super. I don't know, super nodes.
Are you good? And then yeah, that's all I could really say, I think. So yeah, that's everything I've got for you guys. So if you have any questions, just shoot me a DM on Discord or something. I have to take my test, but
Yeah, good luck on that.
thanks, man. Yeah, it's I didn't study for it yet, so I need to do that. Oh man, but okay, so I'm gonna let you guys go. Have a good night. Good luck on the quiz tomorrow. Please do
Good
not sleep through your alarm like that one guy who slept through his alarm for our first exam.
Oh yeah, oh, I
So-
can imagine.
Yeah. All right, though. Have a good night, guys.
Good
You too,
night.
man.
All right, see you.